Hey guys, this is Jessica. I'm a little confused by the stats question. Please, could you help me out? I've been stuck for a while and I don't like this question. Please help me. Bye.
Okay, fantastic question, because up until now we haven't really looked at graphical interpretation. We've only been drawing our own graphs. So let's take a look at this question. It says, the graph below shows the correlation and, okay, that's definitely meant to say shows, not shoes. Shows the correlation and line of best fit of the arm span and wrist sizes of a group of boys. Okay, so these are the variables. Now, if you look here at our graph, we've been given variable 2 and variable 1. We haven't actually been told which is the x value and which is the y value. So let's take a look at the questions. The first one says identify the two variables. Okay, so now this is just using common knowledge. We have two different variables. We have arm span and wrist sizes. So guys, arm span, for those of you who don't know, is basically if I do this, how long are my arms? The span of my arms, that's my arm span. And then wrist sizes is obviously the measurement around your wrist. Okay, so if we look at these two variables, we have one given to us in millimeters and one given to us in centimeters. Which is more likely to be in millimeters and which is more likely to be in centimeters? Well, your wrist is rather tiny compared to your arm span. If I look at my wrist, I have very small wrists, but this is really small compared to the entire width of my arms. So it makes a lot more sense that this tiny little circumference is going to be given in millimeters and this in centimeters. So this is where your logic comes in. Variable 1 in millimeters is definitely going to be your wrist size. And variable 2 is definitely going to be your arm span. Okay, you don't need to give any reasons for that. Secondly, it says list the coordinates of each of the points shown. So what you would have to do is you would have to go and look at the scatter plot and remember that if you're listing coordinates, remember coordinate pairs go in x and y. This we said was the x variable and that is the y variable because that's how graphs are laid out. So obviously for the first point here, x would sit at 150 and y would sit at probably 130 or 131, somewhere around there. And you would have to go and look at each and every one of these points and list their coordinates. What I've done, because I'm not going to have enough time, is I've laid them out in a table. So like we said, that first point sits at 150 and 130, x and y. And these are the rest of the points if we were to list their coordinate pairs. Okay, so go through this and check that you got them right. Now, it says use your calculator to determine the correlation coefficient and describe the correlation that exists between the two variables. So that's why I wanted to save time by drawing out this table, because now we have to put all of this data into our calculator. So remember, mode 2 for stats, and we have two variables, so it's 2a plus bx. Now we enter all the x values. So 150 plus 157, whoa, not plus. 150 equals 157 equals 160,5, 166, 167, 170, 172, and 177. Now for the y variables, we do exactly the same thing. Enter each of your data points followed by an equal sign. 162, 153, 172, 160, and 190. And when you get your table, always make sure that you have the same number of variables in each column. So now we press AC to store all the data, press Shift 1 for stats, and because we're looking for the correlation coefficient, we're looking for regression 5. Remember, correlation coefficient is given to us by R. So we press 3 and equals, and we get 0,9. Now it says, remember, to determine the correlation coefficient and describe the correlation, that exists between the two variables. Now remember, correlation is a number that spans from 0 to 1. It's almost like probability. A correlation of 1 means there is a one-to-one relationship. They are codependent on each other. Zero correlation means there is absolutely no way we can predict one variable from the other. So obviously, a correlation of 0,9 is very strong. So remember, when you comment on correlation, you need to comment on the slope or the strength, and also in this term, the sign of the correlation, because if you have a positive correlation, it slopes that way, and a negative correlation slopes that way. So you really do need to comment on either of them. So for this question here, you would say there is a strong, because 0,9 is very strong, strong positive correlation between the wrist sizes and arm spans of the boys. Let me just double check that they were boys. Yeah, group of boys. Okay, perfect. So now let's check for the last question. It says, use your calculator to find the equation of the line of best fit. Remember, y is equal to a plus bx. This is very easy stuff, guys. This is just going to your calculator. Shift 1 for stats, 5 for regression. A is equal to negative 140,26 plus B, you do the same thing. Shift 1 for stats, 5 for regression, 2 for B, and we get 1,82x. Okay, and that is the equation of the line of best fit for these data points.